Have you ever wondered how data travels in a network? The answer lies in the concept of routing. Imagine you're sending a letter. You wouldn't just throw it into the air and hope it reaches its destination, would you? Instead, you address it, put it in a mailbox, and it begins a journey. It might be sorted at a local office, loaded onto a truck, flown across the country, and finally delivered by a local postman. Routing in a network functions similarly. It's the process of selecting paths in a network along which to send data. Whether it's an email, a web page, or a video, routing ensures that your data packets are delivered to the right place at the right time. Routing is a fundamental aspect of data transmission, and without it, our connected world would grind to a halt. In the world of routing, there are two main types, static and dynamic. So what exactly do these terms mean? Static routing is like your favorite recipe, followed to the letter every time with no deviations. It's a method of routing that relies on a network administrator manually configuring and defining the paths that data packets should take through a network. So, imagine you're the chef in a kitchen, and you decide exactly how each ingredient makes its way to the final dish. That's static routing in a nutshell. In the world of information technology, static routes are like well-trodden paths or highways. They are unchanging, consistent, and reliable. They don't fluctuate with network traffic or shift based on algorithmic whims. Instead, they remain steadfast, guiding data packets from their source to their destination along a predetermined path. This has its advantages. For instance, static routing is straightforward to set up, especially in smaller networks. There's no need for complex algorithms or computations, just a clear predefined path. Moreover, static routes are predictable. Since they don't change unless manually altered, network administrators can have a high degree of certainty about the route a packet will take. However, static routing is not without its limitations. It's like a recipe that can't be tweaked or altered, even if the ingredients at hand change. If a network link fails, a static route can't automatically adjust or find an alternative route. It's up to the network administrator to manually reconfigure the route, which can lead to downtime and disrupt network services. Additionally, static routing may not be the most efficient method in larger, more complex networks. Think of a bustling city with numerous roads and intersections. With static routing, there's no flexibility to reroute traffic based on congestion or roadworks. Instead, all data packets follow the same route, regardless of network conditions. In essence, static routing is like a reliable old friend, always doing exactly what you expect. But what if we want a bit more flexibility? Enter dynamic routing, the adaptable, quick-thinking cousin of static routing. Let's delve into what makes dynamic routing stand out. Unlike static routing, where routes are manually set and remain constant, dynamic routing is, well, dynamic. It uses protocols to automatically change and adapt routes based on network traffic and topology. This means it can easily adjust to network changes without the need for manual intervention. Imagine you're at a bustling city intersection with traffic flowing from all directions. Now, think of dynamic routing as the intelligent traffic management system, adjusting signal timings and redirecting traffic based on the current situation. If there's a traffic jam in one direction, dynamic routing would quickly adapt and reroute traffic through less congested paths. This adaptability of dynamic routing is all thanks to routing protocols. These protocols are like the brains of the operation, constantly monitoring the network and making decisions based on the data they collect. Some of these protocols include Routing Information Protocol, RIP, Open Shortest Path First, OSPF, and Border Gateway Protocol, BGP, each with its unique characteristics and benefits. Let's not forget one of the defining features of dynamic routing, automatic updates. When a change happens in the network topology, dynamic routing protocols automatically communicate this change to all routers in the network. This ensures that every router is always up to speed with the latest network status, enabling them to make the best routing decisions. The beauty of dynamic routing lies in its flexibility. It can handle large, complex networks with ease, making it a popular choice for businesses and organizations with expanding network needs. While it might require more resources and a bit of initial setup compared to static routing, the benefits of adaptability and automation make it a worthwhile investment. Dynamic routing is the life of the network party, always adapting and changing. But how do these two types of routing compare? Static and dynamic routing may seem like polar opposites, but they both have their time and place in network data transmission. Let's delve a little deeper into this comparison, shall we? Starting with static routing, this is a manual method where the network administrator manually inputs the routes in the routing table. This may sound tedious, and indeed it can be, especially for large networks, but it's not without its benefits. Static routing offers predictability and control, as the administrator knows exactly how data will flow. It also doesn't require any extra processing power or bandwidth to communicate with other routers. However, the downside is its lack of flexibility. If a link fails, the administrator must manually reconfigure the routes, which can lead to downtime. Now let's turn our attention to dynamic routing. As the name implies, this method is all about flexibility. With dynamic routing, routers communicate with each other using routing protocols. They share information about the network's topology, allowing them to automatically adjust routes based on the best path available. This makes dynamic routing a great choice for large, complex networks where changes are frequent. But it's not all roses and rainbows. Dynamic routing requires more processing power and bandwidth. It's also less predictable as routes can change dynamically, which can sometimes lead to unexpected data paths. So when might one choose static over dynamic routing or vice versa? Well, for small stable networks where changes are infrequent, static routing can be a viable option. It offers simplicity, control, and doesn't put any extra load on the router. On the other hand, for large, complex networks that are subject to frequent changes, dynamic routing is typically the way to go. It offers flexibility, adaptability, and can automatically adjust to network changes without the need for manual intervention. So you see, static and dynamic routing each have their roles to play. But what about the administrative distance in static routes? The administrative distance in static routes can be thought of as the credibility of the source of the route. It's a metric used by routers to select the best path when there are multiple routes to the same destination from different routing protocols. Typically, in static routes, the administrative distance is set to a default value. This default value is often seen as the most reliable, since the routes are manually configured by a network engineer who presumably understands the network topology and its requirements. Now, let's introduce another concept: floating static routes. These are static routes where the administrative distance can be manually adjusted. Why would we want to do this? Well, imagine a scenario where you have a primary and a backup route to a destination. The primary route might be faster but more expensive, while the backup route is slower but less costly. By setting the administrative distance of the primary route to a lower value, it will be selected first. But if the primary route fails, the router will automatically switch to the backup route, thus ensuring continuity of service. So, in essence, the administrative distance gives us control over route selection. This is particularly useful in complex network environments where there are multiple paths to a destination and we need to balance factors such as cost, speed, and reliability. So, administrative distance adds another layer of complexity to our understanding of static routing. Let's summarize what we have learned. Routing, the silent director of data traffic in a network, may seem complex, but hopefully it's a little clearer now. We've delved into the nitty-gritty of static and dynamic routing. Static routing, as you'll recall, is the manual method of routing. It's a bit like a map you've drawn yourself, with all the paths meticulously plotted out. It's simple and reliable, but it does require a certain level of expertise to implement effectively. Then we have dynamic routing, the more flexible and adaptable sibling of static routing. It's like having a GPS that updates in real time, adjusting the route based on current conditions. Dynamic routing employs routing protocols to ensure data takes the most effective path, making it a popular choice for larger, more complex networks. We also touched on the concept of administrative distance in static routes. This default value is a measure of the trustworthiness of the source of the route. However, we can change this in floating static routes, allowing us to have more control over our network's routing decisions. In the end, whether you choose static or dynamic, it's all about finding the right balance for your specific network needs. Each routing method has its strengths and its place in the grand scheme of network data flow. And that concludes our journey into the heart of data transmission. Remember, whether static or dynamic, each route plays a crucial role in the grand scheme of network data flow.